So activity 3.8 continues with the treatment of logarithms. We start the topic off with the change of base formula. Specifically, we want to change base b to base 10 or base b to base e. So if we have an expression log base b of x, and I want to change this from base b to base 10, I can write log base 10 of x over log base 10 of b. Remember, if there's no number or subscript after the log, we can assume it's in base 10. We can also change it to base e. All right, so if we have log base b of x, well, we can write the natural log base e of x over the natural log base e of b. And again, if there's no subscript next to the ln symbol, we can assume it's in base e. Now you might say, well, why would we want to do this? Well, what if I give you this example? Right here we have x equals log base 2 of 15, and I'm asking you to solve for x or evaluate. Well, our calculator doesn't have base 2. Okay, so if I can change this from base 2 to base 10, then I can enter this into my calculator. Okay, so using the formula up here, we can write log base 10 of 15 divided by log base 10 of 2. Right, so here's our expression, right? Log base 2 of 15. I'm going to rewrite this as log base 10 of 15 on the top divided by log base 10 of 2 on the bottom, and you see we get 3.9069. I could have changed this to base e because, again, our calculator can handle log base 10 and natural log base e. So the same expression, log base 2 of 15, can be written as natural log base e of 15 divided by natural log base e of 2. And we get the same answer. So whether you use log or natural log, we should get the same result. So why don't you practice problems 1 through 4? Maybe pause the video. I'm going to fill in these answers 2 at a time, and we'll see if we get the same results. Okay, so problem 1, we're going to write, instead of log base 3 of 90, we'll write log base 10 of 90 divided by log base 10 of 3. Or in our calculator, that's going to look something like this. Here's the log key. And I'll write 90, like log base 10 of 90. Remember, if there's nothing written, if there's no subscript beneath the log, we assume it's in base 10. Divided by log base 10 of 3, and I press enter. And there's my answer. And just for the record, if I were to write natural log 90 divided by natural log 3, we still get the same answer. Okay, so we've changed this from base 3 to base 10, and we did it again, base 3 to base e, and we got the same result. Okay, and here's my answer. Right, it does say go 4 decimal places. All right, so again, try 2 and 3 on your own, and we'll compare notes. For the problem 2, I write log base 10 of 100 over log base 10 of 5. I press enter. We go 4 decimal places, so it looks like this is going to be 2.8614. And then I'll post the answers for 3 and 4 now. And here are the results for problems 3 and 4. Next, we're going to take a look at the logarithm of a number to a power. And there's actually a little property they give us here. Right, if I have log base b of x raised to the power p, we can rewrite this as p, or the exponent, times log base b of x. All right, so really, we're just taking the exponent and moving it in front of our expression, and it's just another way to rewrite a problem. This will later get us out of a jam. And when you look at example 2, we have log base 10 of 7 raised to the 3. We can rewrite this as 3 times log base 10 of 7. Okay, and I would like to do a calculator check here. Okay, so if I type log base 10 of 7 raised to the 3, whoops, I hit the exponent in the wrong, or the parenthesis in the wrong spot. Here we go. Okay, so I have log base 10 of 7 raised to the 3rd, and it looks like I have an extra set of parentheses. I'm going to press enter. I'm going to do it one more time with only one set of parentheses. 7 raised to the 3. I think that looks better. We get the same answer, right? So log base 10 of 7 raised to the third. Now, the properties of log allow me to write this as 3 times log base 10 of 7. And I did it again. Sorry about that. There we go. One set of parentheses. So it's 3 times log base 10 of 7. And I press enter, and notice we get the same answer, right? So this really kind of verifies that log base 10 of 7 to the third is equal to 3 times log base 10 of 7, right? We just moved the exponent to the front. And they show us a few more examples, right? Here my exponent is 3x, so they move the 3x to the front. Here my exponent is 2x plus 4. It's kind of important to keep that in parentheses, so they write 2x plus 4 as my exponent, and they group it with the parentheses. Last, I have log base 10 of 10 to the 2x. They move the 2x to the front, okay? And log base 10 of 10 is actually 1, so it's 2x times 1, or 2x. So they give us a few practice problems, all right? So maybe, again, pause the video and then complete problems 5 through 7. So problem 5, it's log base 5 of 4 to the 7. I simply take the exponent, which is a 7, and place it in front to get 7 log base 5 of 4. Problem 6, the exponent's the x, so I put the exponent in front to get x log base 10 of 4. Now my exponent's 1/4, so I put the exponent in front, so I have 1/4 natural log base e of t. So now try problems 8 through 10 on your own. So here are the answers for 8 through 9, right? Log base 10 of 10 to the 3x becomes 3x times log base 10 of 10. But remember, log base 10 of 10 is the same as 1. So 3x times 1 leaves us with 3x. For number 9, natural log of base e of e to the 5t. Well, the 5t comes in front, and we're left with 5t times natural log base e of e. And natural log base e of e is the same as saying 1. So 5t times 1 leaves us with 5t. And then the last one, we have natural log base e of e to the 4x minus 1 as an exponent. So I bring the whole exponent in front, placing it in parentheses, by the way. So I'm left with 4x minus 1, the quantity, times natural log base e of e. And again, natural log base e of e is the same as 1. So you're left with 4x minus 1 times 1, which is simply 4x minus 1.